allows me to store data, but has the flexibility of allowing me to insert data in as much quantity as I want. Now, you might say, okay, that was a problem with arrays, right? Arrays have fixed size, right? But then you can say, but Professor, then we had also array lists, correct? And array lists seem to provide that benefit that we didn't have before, right? Because array lists are supposed to be unlimited in size, right? Well, I have to uncover the veil for you. Array lists seem like they have infinite size and they allow you to add everything, but behind the scenes, they are behaving like an array. And every time you say add, it's making twice as big when it gets full. But all of that is going behind the scenes. Remember we did that in class? Remember we did something with arrays, we did that in class? Arrays behave similar, okay? But twice the size. But you don't see that. But if you're talking about memory-wise still that memory is being reserved and used and everything, right? Correct? So, can we do better than that? Yes. And for that we're going to use linked lists, okay? Linked lists are going to be represented this way. If you remember, arrays were represented like this, right? Okay, linked lists, I'm going to represent them like this. If you see books, sometimes they don't like the round shape. And they like going like that. Is it different? No, right? No different, right? Remember I taught this class at Miami-Dade in Advanced Java there? And one of my students did this and he went to Illinois State University or something. One big university there. And he told me that he was happy that he learned that. And when he went there, his professor saw him doing this and he didn't like him. He told him, that's wrong, you should do it like that. That's really stupid, right? There is no right way there. The idea is that you understand how it's connected. Okay, this is how we're going to see a linked list. This is going to represent a linked list, whichever you want to use. I'm going to use mostly this because I don't like doing ages. It's too hard for me to draw them, okay? Now, the idea is that if this is a linked list and you want to add one more element, you can add it at any point. Maybe here at the end, or maybe you want to add it at the beginning, etc., etc. Okay? Now, we're going to have all of this connected. I make an analogy with, for example, have you used these watches, right? Most people use these watches, you have seen them, right? Sometimes when we buy them, these are too big for our wrist, right? And we have to remove a little piece, right? Correct? Some of you don't have that problem, some of you have that problem. I don't know, right? But the idea is that this is made out of many pieces, correct? Right? And you can remove and put them, correct? And one is connected to the other, right? Correct? That's how it's done, right? Same with a necklace from a woman, for example. If you see a necklace, they're all connected, right? This guy is connected to this guy. This guy is not connected to that one, for example, right? And you can add more, no, we are going to call them nodes as you want. You can make the necklace longer or shorter, right? So it's a similar idea what we want to do here. But before understanding how the whole thing works, we need to understand how one of them works, okay? So this is one node. We're going to first learn about one of them. Understand how this works, how it is. We're going to call this node. Okay? Is that clear? So each element in my linked list is going to be called a node. Now, a node is going to have two parts. One portion where you're going to store the data, the information, correct? And another portion that is going to store some way of connecting to the next, okay? It's like, imagine these four guys are my linked list, okay? Each of them is a node, right? So Darlene is my first element, for example, right? Darlene needs to know who's next to her. Imagine if she's looking like this, who's to her left, right? She doesn't care who's before her. She just cares who's next to her. So she says Yukin, right? Now I move to the next node. The piece of data here is Yukin. That's the data, the name of the name of the element, for example, right? Now Yukin doesn't know who's before her, but Yukin has to know who's next to him, so that I can keep moving and traverse the whole list. Make sense? Is that clear? So each node has two parts. One part that is the portion of data that contains the information I want, and another portion that we're going to call it next, that is going to be the piece of data, the piece of information that is going to inform me who's next. in the list. Got it? So far so good? Like if I had an array like this, imagine, 2, 7, 9, for example, if it were a linked list, it would look like this. Portion of data 2, right? Then here a connection to the next node, which should be a 7, right? And then connection to the next node, which should be a 9. And here, say no, there is nothing else. Yes?
Are we using pointers here for next?
In Java, we don't have pointers. In Java, pointers do not exist. We're going to use object references. Okay? C++, probably you did this before. Yes, we use pointers in C++. That's why we love Java, because Java takes away from us pointers, which makes our life so much easier. Okay? So, but so far, I'm just focusing on one node. Okay? Okay, if this is my class, if this is my node, I need to define a class for it, right? Because each of these guys will be an object of the class node. Correct? Is that clear? Is that clear so far what I'm saying, guys? Yes? Each of these conform to this template, right? A data and a next, correct? All of them look like this, right? So all of them have to follow one class called node, one template called node. And each of them is an object of this type. Is that clear? Yeah. So let's start defining how the heck the class node looks. Public class node. Right? Professor, when you say data, does it have to be necessarily an integer like you showed me there?
Capital N, always?
Every time you define a class, the class name should be starting with capital. It's a standard. Doesn't have to be like that. If you write it with lowercase, it still works, but that's not the standard. Okay? Okay. Does the piece of data have to be an integer?
No,
Can be anything. Could be a class soda, and each node could represent a soda object as a piece of data. Got it? Could be a double, could be a string, could be anything. Is that clear? For simplicity, we're going to create one node where the piece of data is an integer. Seems simple? So we have data. So we should have private, the name of the attribute, right? Private, and here next, right? The question is here. Okay, we decided the data was going to be, in this case, an integer, right? Okay. What should next be? Okay, somebody else? Another try?
Double.
Okay, let's play with the possibilities. We have agreed that data is going to be an int. We said it doesn't have to be. Could be soda, could be person, could be anything, right? But let's say we want to keep an integer in the node. What do we put for next?
Node.
You say node, Carlos says node. You say double. Let's play with double for a second. If I were to put double here, next would store a double, right? What double could tell me who's next to me? There is no way to have that information in a double, right?
Oh, Boolean, right?
A Boolean, that would tell me true or false. That could tell me just as this much. I have somebody next to me or not. That's as much as a Boolean can give me. But cannot tell me who's next to me.
Oh, like what exactly? Oh, I can.
So a node has to have a piece of information, the data that he carries, plus who's next to him. Got it? Okay, the data that he carries can be anything. We have agreed that for now we're going to play with integers. So in data. But how do I know who's next to me?
Node.
It has to be node, because next is pointing to another node. Correct? And here's where people start getting a little confused because they say, I'm just defining the class and I'm already using it. That's fine. Don't worry about it. Why? Because your node has a next that is pointing to yet another node that is just like you. So it should be also node. Is that clear? Yes? Look, I have started doing drawings here, right? Look at kindergarten, bubbles and colors, right? Extremely useful, guys. If you don't use them, you're going to get lost. Trust me. Do you have your laptop up? Let me help you. Work with your laptop, because this will take forever to set up. We're going to lose time. Thank you very much, man. You're going to point, maybe you have to log in, right? Okay, put it there. I'm trying to tell you that. So far, so good, right? Yes.
So you end up just making a list of what's coming next?
Don't worry about the list yet. Don't worry about the whole list yet. For now, guys, put your 100% focus on how one node works. Okay? Just one node. Simple? Then once you're completely familiar of how one node works, how we make connections and everything, then we're gonna see how we can make the whole thing, okay? For now, forget about the whole linked list, just focus on one node. So today, we're gonna start with node. Maybe we're gonna reach linked list, I don't know yet. But at least I want you to understand how a node works. Yes, sir?
It's gonna be one type of list, like one data type, or they're all integers?
All of them have to be integers, because you're defining a node, and all of them will be of that same class node. So all of them will look the same, okay? Yes?
What's the difference then between a node and I guess inheritance? Like it's inheriting all the other subclasses, wouldn't that kind of be like a node?
No. We're defining one node is just one element meant for here. Inheritance is something else. Inheritance is when you're getting attributes and methods from your parent. We're not using parent classes here at all. Not yet. We're going to complicate things later. So your request. So we have defined our public class node. I'm going to write it all in the computer. It's going to be a little fast. Okay.
Why again was it not Boolean, private Boolean? Why we said that?
If I put boolean here in their link, remember, the next is for me to know who's next to you. If I want to put boolean here, the link next would have only two values, true or false. The most that can tell me is if you have somebody to your right or not. That's all.
But when you say, yeah, there is somebody, it's true.
Correct. So I know who's that somebody. Can I access from you, the next guy? Can I access the guy next to you from that information?
Oh, okay.
Correct? If I tell you, Darlene, do you have somebody next to you? You tell me yes or no. Do I know who's that person? Can I reach that person?
Oh, okay.
No, right?
Okay.
But if you tell me yes, and that person is the guy wearing red, for example, you give me information, and oh, then it's you.
Okay.
Got it? So I don't provide that much information with just a true and false. Yes?
Wouldn't that use more memory than array?
Wouldn't that just use more memory than arrays? It's relative. It's all relative. Look, if I create an array of 1,000 elements, and I only need 3 elements, how much space am I wasting? 997 spots, right? If it's of integers, multiply that times 4 bytes, correct? So we're wasting like 3 KB average, right? If we're doing linked list and you need 3 spots, you just use 3 nodes. So you're saving a lot of memory. Now if you have an array of size 3 versus a linked list of size 3, yeah, the linked list could use a little bit more memory than the other one, right? But with linked list, you use memory as needed. That's the big thing. You use memory as needed, okay? I'm gonna call it linked list. Manny, in your class, probably you just imported the class Java list, linked list, right? Okay. So you've used at first, at class, you've done that, right? No? Okay. You should learn that. Guys, for the big companies, such as Microsoft, IBM, Google, etc., their favorite questions are linked lists. That's their favorite questions. Because that requires a lot of thinking. You're going to realize later.
What'd you say?
They ask a lot of questions on linked lists. They love those kinds of questions because that makes you think a lot. You're going to see some. Because they care about efficiency sometimes. So we define our class node. So we write private in data. That's to define our portion of data of the node, right? Correct? Now, private node next. That next is going to tell me who's the node next to me. Correct?
Yeah.
Got it? Since we are drawing it in this fashion, since we are drawing the nodes like this, would be the next would be, if I'm talking about this node, for example, who's next to me? Who's to my right? Could be this node, or could be be nothing if he's the last one, right? Correct? Okay. Now we're going to create a constructor. Public node. Options to create a constructor. One option is to do it like this, like you guys are used to. And then node end, right? And here I would say data equal D, and next equal N, right? That's one option, right? But let's analyze what that constructor indicates. What does that constructor tell us? That constructor tells me the first time, in the beginning of times, do we have any node? There is no node. No node exists. Correct? Now, let's assume for a second that some node exists. For a second. And I want to create this new node, this red node. And I say new node. Okay? Let's call this node, for example, N. Okay? And let's call this node N2. Sounds good? So you want to create N2. So I would say node N2 equal new node. Correct? Let's say I want to put a 9 here.
Oh, what?
A 9. 9 comma, because I'm going to use that constructor. That constructor tells me whenever you want to create a node, you have to provide me a piece of data, D, and who's the next node? N, right? So I could do this, right? Comma, N. Correct? I could do that, right? Correct? In this case, I'm saying I want to create node N2 where the data is 9, correct? And the next is N. So if the next is N, this should be like this.
Right.
Right? Do you understand what I'm saying? Yes? Is that clear? If you're saying 9, comma N, you're saying the piece of data is going to be 9, and connect, your next is going to be N. But N is the blue guy, so it's there. Sounds good?
So you're going backwards now?
Not backwards, man.
I mean, I'm
You're
saying you add in that 9 on that previous element, right?
What'd you erase that?
Yeah, it goes from
So you don't see backwards, because I don't want you guys to get confused by that. This can be anything, say 7.
But it
What?
attaches to it from the left.
What I'm saying is, first you have node N. This is what you have first. Imagine a node N with 7 exists. That already exists. Okay? Somehow magically it appeared. Okay? If somebody does this piece of code, what he's saying is create node N2. Okay? This is how a node looks like. Put that as data 9. And the next of this node N2 should be N.
Is that a G?
9.
You see an integer, there is not a char, so figure it out. So you put N here, right? So that's what you're saying. Got it? Is that clear? I'm saying the node is 9, and his next is N. So this is N2, and his next is N. That's what the red line is doing. So far so good?
Yes.
This sounds kind of weird. Seems cool at this point, seems cool. This is not wrong, this is right. But what happens when you are really talking about the beginning of times? You won't have any node N in blue, right? So what you want to do the first time is be able to create any node, put any piece of data, or any integer for the piece of data, and there is going to be nothing. He's not going to be pointing to anybody because there is nobody yet, right? His next should be pointing to null means no other object. There is nobody to my next. That's how the first node should look, right? So we should create a constructor that just receives the piece of data because initially we don't have anybody next to him. Got it? So we should do this guy. The next put into null, and you don't have to receive any node, just receive the data. Got it? Just receive the data D, put the data right there, and his next make it null, because there is nobody else. And that's the constructor we would use the first time we want to create one node, for example. Correct? Got it? So if we want to call this node, say, M, this would be something like this. Node M equal new node with an A. And that would create that.
So Professor, you're saying the first node is not given any information, it's just...
What I'm saying is the first node doesn't have a person next to him. Correct? You understand what I'm saying?
A little bit.
Okay. Okay, let's say you come to the room. Nobody else is here, and I ask you, who's to your right hand? What would you say?
There's nobody.
Nobody, right? But then when I add another person, that person I can say, oh, now that you're getting in the room, put your right hand next to Gregory, for example. Correct? I can do that from the second person on because there is already somebody. Correct? But for the first person, I cannot do that. So I have to say, his right hand is pointing to nothing. Correct? So that's what I'm saying. You can create a node, put the information that you want, but his next is pointing to nothing because there is nobody yet. But I have to allow the possibility of putting null. That's why I'm creating a constructor where I'm just receiving the data and pointing to none. This constructor that I just made here, this little constructor where it's putting next to null, allows me to create nodes that are not connected. Got it? Independent nodes. Is that clear so far, guys? Correct? Now, the second constructor that I have put there allows me to create a node and at the same time connect him to an already existent other node. Is that clear? Yes? So the second constructor, if I do something like node, for example, M2 equal new node 9, M, I'm saying create a node called M2, put a number 9, and connect him to node M. So this guy will be connected to that guy. So I could do this if you want to. Got it?
Now, can that, from that node, can that one connect to another one, another one, another one?
You can do as many gates if you want. You're going to see that soon in the main. You're going to see how we can manipulate and make crazy connections. Okay?
No, what I'm saying is like, can that node be connected to two at one time?
Okay, good question. He's asking, can one node be connected to two nodes at the same time? Under this assumption, what do you say? What do you say?
That's called a double linked list.
That's a double linked list, and we need a special type of node, right? This node has a next, doesn't have a previous.
Next line,
Next is just, it's like you have just one arm.
right, so next will be next line,
So you can always point to one guy only.
or next dot link,
Sorry?
or would it be like a next dot link?
Next at length. Remember, next
The
is
next
just,
is two of them at the same time, I don't know.
you can, because you can just have one next.
No, not in this one, but the double.
But you can add a previous.
Yeah, but you will have to change. For example, you could create private in data, private node left, private node right. So now your node has left and right. You can connect two nodes.
That's binary tree, right?
That's more of a binary tree, yes. But so far, don't worry about it. So far, simple node just has one arm. It connects to one side only. Okay? So under the kind of node that we're building, you can only point to one next. Okay?
So can you also say like a double link, like saying like, node left, right, up, down?
You can do crazy stuff. Yes, that's creating meshes. Mesh. You want to create a mesh. If you have up, down, left, right. Yes.
Are they building from right to left? Like, for example, like an array, when you keep adding one, an array list, it's just one, and then it gets another one, and then it gets another one.
Same idea.
So this
Same
one-
idea. That's what I'm
It's
saying.
like it's going backwards. Like, start from the last one, and then you should go.
Not necessarily. Not necessarily. Here it allows you to insert any place. Any place. In an array list, the same thing, man. I can say add at 0. If I say add, if I say just add, it will put it at the end, right? But if I say add 0,7, I'm going to add the 7 at the beginning, right? Or I can even say that in the middle if I want, right? Add at 5,3, it's going to put in position 5 at 3. Right? That's array list, right? So, there is no such a thing. Okay? Is that clear, guys? And what if I feel like doing this? So, let me start drawing here this little piece. Can I do something like this? Node M3 equal new node 12, comma, null. Can I do that? Also, I can do that, right?
So you do it an
So-
independent one?
Yeah, so let's start doing how does step 1, how does step 2, and how does step 3 look. Step 1 has to go first, right? If this is the goal, this has to go first, right?
Okay.
This will create a node with 8 and pointing to node. First time, this is node M, right? Now I'm creating node M2, okay, M2. I'm putting a 9 and saying your next is M. This is happening, right? Again, we're not doing linked lists yet. We are not doing linked lists. We're just playing with nodes and trying to connect them. Then I'm saying node M3, 12, node. Okay, M3, 12, node. They're not connected. The blue guy is not connected to anybody. Right? Clear? Valid? Yeah, why not? Right? Clear, guys? Now, if I'm going to use this type of constructor, put null all the time, I don't really need the first type of constructor, right? But this is more comfortable. Right? So we're going to have the flexibility of having both. So far, so good? Yes? Okay. Getters and setters shouldn't be a problem, right? Insert code, getter and setter. Okay. Now let's play here. Let's create node M. Make one new node. Then we put a name, right? Then we set node M2. And we want to create here 9, M, right? And then node M3 equal new node 12, node. How does that look? Just like this. Right? Correct? Is that clear? What if I want to print, for example, data from M? How would I print the data from M?
And
That's the data, right? Correct? Is that clear, guys? I just asked the node M, what's your data? That's it. Correct?
Mhm.
Yes?
Yep.
Okay. What if I want to know the data from M2? Let's do it this way first. I could do M2 data, right? Correct?
Yep.
Right? Another way. Okay. We want to bring what's the data of M. We ask you, M, the data. And that should tell us, right? If we run this code, it should tell us whatever the data is, right? Correct? So far so good. It's going to give me 8, for example, right? Print out 8, right? Now, for M2, I want to know what's the data, right? So, how do I do it? M2 got the data, right? Actually. Okay, that's clear, right? How we get data from M and M2, right? Now, let's analyze this a little bit. Doesn't it look like I have M2 connected to M? If I wouldn't have access to M, could there be a way for me to print the data of M? Like, imagine for example,
M2 get next.
let me put it this way. Imagine these two guys are here. This is M2, this is M. Okay? So I can ask, if I have access to Yuken, I can ask directly, Yuken, what's your name? He says Yuken, right? And then I can ask Darlene, what's your name? She says Darlene, right? Now if I only have access to the Darlene, imagine they put a barrier here. He cannot hear me. And I ask, and I have access to Darlene though. Would I still know the information from Yuken? Right? Because Darlene is just next to Yuken, right? So I could have Darlene do the job, right? Darlene could access Yuken, and once she's on Yuken, now that name can come. That's clear?
So you could use M2 that node. You will call the method.
Good, close. M2, that node. Is that node? Get next, right?
Get next.
So if I call M2, give me your get next. Get next from M2 should be this guy, right? Correct? That get next from M2 should be this guy, right? Is that clear? All of you guys, is that clear?
Yes.
So if I have M2 that get next, now we're talking about that black guy, right? If we say that get data from that piece of information, then we have the data from M. Is that clear? Yes? So I could do this by saying M2 that get next. All of this piece of information is already M, right? Correct? M2 that get next. Now we're talking about M, correct? And now, if you're going to see the first line and the third line are going to print the same. 8, 8. Got it? Is that clear, guys? How are we getting that to work? Because they are connected. Okay? Is that good? You don't get it?
All you're doing is going from, so you're going backwards, you're going from 2 to 1 to get into the data from there, instead of going from 1 to
Sorry?
2. You're going from M2 to M.
Correct. That's how do I go from M2 to M? By calling get next from M2.